Hi, today we will be getting ShiftScan installed as well as instructions or directions to get both Python and miniconda installed, which it needs to run. The first thing we're going to do is check Python. So you can open up a new terminal. So I have it right here in the dock, but generally for Macs, you go to the Launchpad, Other, and then you go, terminal should be in there somewhere. There we go. So we can just open up the terminal. All right, so there's kind of two ways. Depends on your system. You can try Python -- version. That may or may not come up with something, but more specifically, we want to be Python 3 -- version. All right, if at any point Python 3 point something comes up with either of those, you are good to go. You can jump ahead to the miniconda installation. If nothing comes up and says Python command not found and Python 3 command not found, you're going to have to install Python. So I have Python installed, but I will just move through the steps of how you would go about getting it installed. To do that, we're going to open up our browser. I'm going to go to python.org/downloads. Oh, there you go. It's all done for me. Isn't that nice? Downloads. Hit enter. It should pick up, what system you're on. And you can just press the little yellow button here. Click. Downloads in little to no time. It's up there. It may be in your downloads folder if you need it. Depends on how your computer's set up. But you just click on that, and away it goes. We are going to click continue all the way through. We're going to agree to things, and we're going to say install. I work for the NIH, so I have this extra level of security. So you can go ahead. You probably won't have this step, and then install. And off it goes. Right, this takes a couple of minutes, so I'm going to pause the video here and restart it when, there you go, 2 minutes, when it's all done. All right, we are almost done here. Let's see, any second now. There it is. All right, so this is going to pop up, but it's not actually done yet. If we click back on this window, it's still thinking about life. So don't do anything just yet. It's doing things, and there you go. So when it says congratulations, it's successfully installed, then you can say close. Right. Do we want to move the installer to trash? Yes, we do. We don't need it anymore. We can clean up our system, move to trash. Happy with that. The one and only thing you're going to want to do is double click this install certificates, and basically that just ties up some loose ends for Python. So we double click. That's going to open up a new terminal for us. And I already have Python installed, so it kind of says, I've got everything I need. What are you talking about? But if you are installing Python for the first time, this may come up with a lot more stuff, and it's going to take a little bit longer. But as soon as it hits this process completed step, then you are good to go. You can close the terminal. Close that one too. Right, you can close everything really. And so when you do open up, you might need a restart. In other words, quit on your terminal, close it completely, and then start it up again. I don't think so, but just in case. If you have trouble, that may be a quick and easy fix there. Right, so you should then, once you type in Python 3 -- version, you should have something come up. Now, please, if you do have trouble with this, let me know. So shoot me a message or put an issue into the GitHub repo, because I want to make this as easy as possible, and I'm obviously not aware of everything that can go wrong. So yeah, just let me know. The next step is to get miniconda installed. So to do that, we open up a new terminal window if you haven't, and then right now, if you say pwd, which is point to working directory, where am I in my system? I'm sitting in my user profile. I'm just going to move, so cd is change directory into documents, and say enter. Right, and now I'm in documents, so there's nothing in there. Same thing if we go here, say documents, empty. Great. We are going to go to the miniconda website. The site is in the GitHub repo. If you want to just copy it, that's going to be a lot easier than typing it out. But ultimately, we're going to go to https, and then we say docs.anaconda.com. Oh, there it is. Okay, great. So it's anaconda.com/miniconda/install, and that will take us to this page. So we are a Mac, so we're going to go down here to the Mac OS installation. We're going to go to the terminal installer, and we're going to scroll down. So if you have an M1 or an M2 chip in your computer, you're going to want to copy this line here. You can just click that little guy there. If you have an Intel chip like me, you're going to want to copy this one. So just pick what's right for your computer. So I'm going to go ahead and just say copy. And we can pretty much close that now. And so here in my terminal, I'm going to say Command V, paste it in. And basically all this is doing is copying the installer down from the interwebs. It's kind of yanking it down. So we can hit enter on that. It doesn't take too long. You can see it's starting to download it into documents where I am. Really doesn't take too long if I remember right. There you go, all done. Right, so the next thing we're going to want to do is actually run this. So we just type in bash miniconda. Yeah, so I tab completed there. You can type it out if you need to. And that should run the installer. So now we're going to have to run through the user agreement. By all means, sit and stay with me as we move through this in the video. I will put a little chapter in so you can jump ahead to when we are done with this. But basically, we just say enter and then we hold enter. And this is long, and I'm sure they're trying to force us to read it, but life is too short, so I'm just going to hold enter. And as I said, you know, I'll put a chapter in, and feel free to jump to the end when we actually get through all of this. God, this is longer than I remember. All right, here we go. Okay, so we've reached the end. I've hit enter one too many times. And all I say, do we accept them? Yes, we do. Right, it's telling me that it's going to stick miniconda into my user profile. That's fine with me. If you want to put it somewhere else, go ahead and change that path. But we're just going to say enter because we're happy with that. Off it goes. Somebody thinking about life. All right, I'm going to pause it until it's actually done something exciting, and then we will be back. All right, it's got us down to here. Basically, do we want to initialize it? And yes, we do. So we type in yes. Okay. On the off chance you panicked and said no to that last bit, you can always just run, you can basically CD to get to your user profile. You CD into, so do this, you can see everything there. You can just CD into miniconda and then bin, and then you're going to run conda in it, and you would hit enter, and that would do the same thing. So hopefully you didn't panic though. So that is conda is basically installed, but it's not sort of running yet. There's two different things. You can either close this terminal and then just open a new one, and you should see it. Another way you can do it is you can just source. Actually, you know what? Let's just close it. Let's just make things simple. So we're just going to close the terminal, and then we open up a new one. And now you should see something new here, which is this base. And that is basically your base environment in Conda. And the next step, close this. I've just realized it's still sitting open. You can delete this as well if you want. You can just go ahead and move to trash. We do not need that anymore, in much the same way we didn't need the Python installer. Right, and so we have our base environment, sort of like, you know, your entry hall if you want, and you can start creating new and exciting environments, and the main one of which is going to be ShiftScan. So what we're going to do first and foremost, I think, is not a lot of people will have Git installed. So we can install Git pretty easily with Conda. In our base, you just say, what is it? Let's see, it's Conda install. I'm going to say Y, so we don't have to say yes to all sorts of things. That's basically just automatically yes. And then we're going to say Git. That's what we want to install. And off it goes. It's going to think about life for a second. Off it goes, installing all sorts of interesting things for Git. And then we're done. Okay, so Git's installed, and that's basically just going to allow us to clone the repo from the GitHub. Well, clone the GitHub repo. Anyway, so the next thing we're going to type in is, so here again, where are we? We're in Simonson. Let's go to Documents again. So we're going to CD into Documents. If you ever need to, reset yourself, you just say CD, enter, and you're back at your user profile. And we can go into CD Documents. Okay. So again, we're just sitting in that Documents folder. That's all we're doing. We're not in the matrix here. And we're going to type git clone, which is basically please copy github.com, which is the website. We're going to go to samshay42. That's me. That's my profile. And we're going to want the ShiftScan.git. Capital S on the other one there. And basically that's just now going to copy the entire repo down into onto your computer. So you say enter. So now it's going to copy all sorts of things, and we can say ILS, and we can see there's now a ShiftScan folder, or if you want to look at it visually, there it is. Right. What we're going to do now is we're going to move into that folder in the terminal. So we're going to go CD into ShiftScan. So change direction into ShiftScan, and then within that we're going to move into the scripts subfolder. So CD ShiftScan scripts, enter. All right. Now we're going to create that Conda environment I was talking about. So we're going to just check that everything's there. Yep, everything's there. All right. So we're going to say Conda and create. So basically create an environment, and the file that we want to use. So --file equals shiftscan.yml, and that file basically has everything that Conda needs to create this environment. And so you can go ahead and hit enter. Off it goes. So this may take a few minutes, so I'll probably just pause it here and come back when it's done thinking about life. Okay, so we are done. Basically, the ShiftScan environment is now ready to go. So we're going to go ahead and just copy this bit here. Let's see. Conda activate ShiftScan. You're going to have to run just this one command each time that you want to run ShiftScan, right? But we'll get into that in a minute. But basically, it's installed and it's good to go now. So you say Conda activate ShiftScan, and you'll see that base turns into ShiftScan. We have now moved from our entry hall, if you will, of our house into the ShiftScan room. And so we have all the tools we need to do. Right, the first thing we're going to want to do is basically test that it's working. And to do that, we're going to run it with the example input. So again, if we just say ls, it comes with example input and example metadata. This is in, I guess the Roche format it was, but the default. So I think that's Roche, yeah. So we can just go ahead and run Python 3. Basically, what language are we going to be using here? Multiprocessor _ main. So this is if you're doing the RAM in intensive mode. Plate-wise is there, obviously, and you can run that instead. The RAM one's actually, for the example data, this is absolutely fine. It's just a small little bit. So anyway, Python 3, multiprocessor main. The input is in example input. The metadata, oh, if I spell it right, is -m example metadata, and it's metadata dot dot, oh my goodness, txt, and then we can give it, what are we going to call it? Let's say shift scan demo output. You could say example output, it doesn't really matter. Oh, actually, you know what? Let's do this so we can see at the same time what's happening. So if we go to documents, if we go into the ShiftScan, scripts, there is all of it. And we're basically sitting in this folder at the moment right here. And what we're doing is saying, hey, use Python, run this program with this input, this metadata, and create this output folder for me. So you're going to hit enter, and it's going to start thinking about life. And it's going to, there it goes. Surprisingly slow on its first run. Anywho, it's going to run, basically it's firing up the Python, the ShiftScan algorithm. It's going to start sticking out some messages to let you know that it's running. Sometime this century, it's normally not this slow, but I guess new computer, new environment, first time is probably a little slow. Right, so it's made just this stupid temporary file. You can definitely delete it when it's done running. It should make should be running faster than this. Oh, we'll give it a minute. It could just be because it's an entirely new system, and it's the first time it's running. I've run this so many times on my normal computer that I think it's somehow just ready to go. Okay, here we go. This is actually it moving. All right, so it's made the output directory, and it tells you what it's up to. It's reading in that metadata. It was fine. Onwards. Control columns by default are columns 1 and 2. You can change that. Please have a look at the GitHub repo if you want to look at how to change parameters. By default, the data is normalized, and then it starts actually processing the wells. It tells you how many, so that should match the number of wells you had. And then it runs through and does some QC and starts knocking out all sorts of things. And then as soon as his analysis is complete, you should see all your finished folders there. Files. So you can go ahead and that's basically everything you're going to need to do it yourself. It will have the estimated melting temperatures, etc., etc. However, if you do want to use the visualization tool, you can go ahead and type in Python 3. Again, we're sitting in the scripts folder. So Python 3 visualization.py. And we're just going to, what do we call it? Shift scan. It's input. Shift scan demo output. Okay, so basically you're just pointing this program to where your output is. And you can say enter. And it's going to take a minute again. Now what it's doing is it's firing up a dash. We're going to allow that. It's firing up a dash application that it's now running. You can see dash is running on, so you can just copy that. So Command C, you go to Chrome or whatever browser, and you would paste that in. And this is basically just your local server, so you don't even have to have the internet on for this to be working. So you hit enter, and here we have the visualization. So we can go to the plate overview. This is basically if just things failed. Again, by default, if more than 8 wells fail, the whole plate is said to have failed. You can obviously change that depending on what and how you want to run your analysis. And then this is just, if the same well is repeating in all the plates, that something might be a little bit wrong. Controls, we can just look at how controls are distributed between before and after it's cleaning. And the cleaning is basically, it just removes serious outliers. And some are definitely better than others. But for example, here you can see, I think this is the one that failed. I don't actually remember. These are where the majority of the controls are, and there's a couple of weirdos here, and they get chopped off and taken out of the analysis. And again, you can sort of, if you feel like it, you can scroll through and be like, oh, why did this one fail? And this one is more than 1.5 standard deviations away from the mean of the controls. Again, you can change that 1.5 to whatever suits your needs. You can go ahead to the GitHub repo to see all those parameters. This is one of the more useful pages. So there we go. We can see. I suppose we can make this bigger. Just see everything. This you can see either colored. Each well is colored by the melting temperature of that well, or you can switch it to the Z-score, which is our new and funky way of determining hits. You do not need to, use that by any means. We can scroll down as well, and it's got all our different plates. I'll just go back to melting temperature because I like how it looks. You can sort of hover over all the different wells, and it'll give you information, which fraction it is. If you used fractions, its melting temperature, blah, 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 blah. And you can also click on that well, and you should have the curve come up. So that is the original curve. That is not the first derivative. That's just the original. And you can have a look at what your wells look like. You can look at a failed one. Be like, wow, can see why that one failed. And you can do that and inspect your data and sort of have a little look. This is really nice for finding edge effects. If the colors around the edges are looking a bit wonky, or if you can see patterns and maybe there was some pipetting issues. So that's useful for that. And then finally we have the hit list, which is really the business end of all of this. So by default, it uses our funky new Z-score hit definition. However, if you feel more comfortable using the traditional standard deviations from the control means, or n number of degrees from the control mean, you can go ahead and do that. Let's just do this and say, 2 degrees away from the average control melting temperature is fine with me. I only want to look at stabilizers, and you know what? I'm going to allow down to the relative amplitude. So basically, of your your experiment curves, how their amplitude, how does that compare to the average control? So here I'm allowing it to be as small as 1/4 of the amplitude of the control curves, and 1.5 times as big as the control curves. Then we just hit update, and then we have all our hits. We have a total hit. Obviously, destabilizer we 0 because we don't want any of those. You can then click on each row, and it will open up the original curve as well as the first derivative. The blue little dotted line is the melting temperature of that particular well, and the red is the average control melting temperature for the whole plate. Not for the whole plate, for the controls of that plate. If you decide, hey, this is a really, terrible curve or whatever, and you don't like it, you can just delete it and it goes away. And you can sort of do that for all of your candidate hits. Another thing you can do is generate all the curves, so give it a minute. If you have over 50 hits, it will only display the first 50. Unfortunately, this is not anything I have control over. It's just how Plotly sort of functions, where technically it could produce over 50, but they start getting squished and moved and sort of morphed, and it's just a big mess. So I've limited it to 50. So there we go. We can look at all of our curves. Another thing you can do is to generate the summary graphs. And that basically looks at your distribution of your hits. So these are not a hit, these are the controls, and these are your hits. You can see like, oh, why is this not a hit? And you probably find, there you go, the relative amplitude, whoopsie, is 4.7. So this has a huge amplitude relative to the controls. And so it got booted out. However, if you changed, this to 5, it would be considered a hit. So, different. Oh, and it's also a destabilizer. It would be, because the melting temperature's gone down. Oh, but same thing here. Here we go. So amplitude is 2.17 times as high. It's higher than our cutoff, so it wasn't taken as a hit. If we change this to 3, that would be accepted as a hit. This is really only useful if you have fractions, or some level of separation, maybe different concentrations, that sort of thing. And, so on plate 1, most of the hits came out of fraction 1, and on plate 2, most of the fractions came out of, hits came out of fraction 4. And this is just the, the flip way of doing things. So say, for example, you're now happy, you've deleted everything, and you're happy with your hit list. You can hit export. Okay, well, that's just because I have, whatchamacallits, there's a lot of firewalls. I don't know what the correct term is, but basically because NIH. But it should work fine on a personal computer, and basically all it does is it exports your hit list to a Excel file. And I'm sure if I faffed with it for a second, I'd be allowed to keep it. And that's pretty much everything there. You can go ahead and close that, and then when you're here, you just say Control C, and it shuts down the whole thing. Now, you are probably wondering, I have my own data. How do I do that? And so at any point, let's just close everything and pretend we are starting from scratch. You have your own data. I don't have any on this computer to show you, but we can sort of run through what we would. Yeah, we can make some up. Let's say we have documents, and we're going to make a new one. We'll just say new data. That's what we're going to call it. Put over there. Go in here, and then you would have a folder saying raw input or something like that. Ooh, wow. And then you would have a folder for your metadata, whatever, again, whatever you want to call it. And obviously within there, I would have all my raw data files, and in here I would have the metadata file. Again, if you want to look at format, please look at the GitHub repo. Additionally, we only have 2 acceptable input formats at the moment, because I don't have access to every instrument known to mankind and what the output from the instruments looks like. So if you want a new, if you have a different instrument that's not one of our 2, please go ahead and let me know the format, and I will add it to ShiftScan, and we can get that done. Anyway, so let's just pretend that actually has files in it. So we're going to close. So where is that? That's in our documents. Right. So we would open up a new terminal. Again, you can go to Launchpad and wherever else you want to keep it. And it's going to open it up. Right. First and foremost, we're still in the base. We're going to want to say conda activate ShiftScan. So you have to do that each time that you want to run it. And here again, we're sitting in our user profile. We don't have anything there. We want to move into documents is where we kept our ShiftScan, and then scripts. So this is where we're going to be running ShiftScan out of. And in this case, I'm not actually going to run it because we don't have anything in these folders. But what I would do is say Python 3 multiprocessor main.py. Again, if you're using Platewise, totally fine. Just use that one instead. But I tend to like using the RAM intensive because it's so quick. And generally you can get away with a 10 to 12 384 well plates on RAM intensive on your local computer. It's only when you start generating, more than that, I guess, yeah. It depends on your RAM. If you have 16 gigs of RAM, you can do about 16 plates at a time. If you start looking in the hundreds, you're going to want to go to Platewise or put this on a server. Anyway, I digress. To run it on your own data, Python 3 multiprocessor main.py. Wow, multiprocessor main.py. Input data is in, let's see, it's in users, me, documents, and then we have it in new data. Right, so that's the input. We've now told it where to find it. You will obviously be different. That will be your name and wherever you've put your data. The metadata, same thing, is in users, me, what do we call it? Metadata, oh, good Lord, Samantha. Documents, new data, metadata, there it is. So again, we're just following that chain, and we would call it, I don't know, again, there's no file in there, but it's just pretend .txt or, whatever you called it. And then -o is our output, and we would make that same thing. We're going to go into new. Ooh, I've just realized we made a mistake. New data. We didn't tell it to go look for the raw data. So this would be raw input. Okay, there you go. Let me drive to the end. And this would be users, me, documents, new data, and then again you can call it whatever you want. New data output, and you would run it, and it would do exactly the same as we did with the example input. It would run and it would tell you all sorts of things. And again, when you want to use visualization, you would type in Python 3 visualization.py-i, and then you would point it to this output folder, and then it should be running just fine, exactly as we did with the example input. And yeah, that should basically be everything. So each time you want to run ShiftScan, you have to activate the conda environment, navigate into the ShiftScan folder or the scripts subfolder in ShiftScan, and then from that point, when you're in there, you can point to wherever you want the data. If you're a bit more savvy with the command line, go ahead and add the ShiftScan scripts folder to your path, and you can run it from anywhere. Yeah, that's pretty much it. If you have any questions, any problems, please go ahead, either send me an email or log an issue on GitHub under the ShiftScan repo, and I will do my absolute best to help you out. But yeah, great. Thank you, and good luck with your analysis.